like MySQL where you can cache queries and the such. So you might say that the databases are fine-tuned and how slow is disk reading and things like that. So I have some numbers for you, and this is them. That on a regular computer, these are some numbers which I pulled out from a Stack Trace website, which shows us just how fast cache can be. So the cache part is, if it's a local cache, it is just the main memory reference or the L2 cache, depending on how it's designed. And if it's a remote, you would have that RAM access plus this network access, how fast your network is. And then you come down here and you can see how exponentially larger the disk reading is. So disk reading is much more slower than and plus the big part is that IO blocks, even if you do it with the new IO in Java, there is an overhead of resources, the number of resources that are available to your box itself, and a subset of that would be available to your JVM. So instead of simply trying to put that to the maximum, it is far, far better to cache it and get all kinds of benefits, from free time for your app server to higher usability for your users. So this data is from ServerFault. Okay. So now I'm going to jump into a little code and to help you guys, to help you folks to see a cache in action in 10-15 minutes after this talk. So if you go to this and download Quick Cache, which is a kind of a memory implementation in pure Java. So the only thing which you require to run this is Java, and in the download pack it has a SH file and a BAT file to run on Windows or Linux, depending on what you have available. And this is the short command you would give on the command prompt to get it running on port number 11212. And I generally, the default we do is 11211 and 11212. Right, so once you do this, you would have your running, and you can test it from another terminal by doing these commands. So basically I'm connecting to that same port, and I could say get key, I could say set key, and you can just copy this, figure out later what it's doing, but it's basically telling the system to store a key with the name key1, and what the expiry is and how many bytes will be following, because it's a telnet kind of test application. So then ABCD over here is the actual data which I'm sending to here. So this is the set command, and then I'm saying that I'll be sending, the expiry is 3600, and I'll be sending 4 bytes, and these are the actual 4 bytes. And then the server is telling me that it was successfully stored, and then I can get it, and I can again verify that what I sent ABCD is what I got back. Right. This is a test application which I will give you the URL to, where you can go and download it. It's built by me, it's freeware. You can get the source code and jar to run. So it basically, on the command line, you can tell it what the servers are, or through the source code if you want to edit the source code. And you can set different values and give it a TTL. So TTL, the name of the key is here, A key. This is the value over here. And then this application has some messages to help you understand. So I've run 2 instances of the same application, and you can see that it will get the remote server. So this is some of the behind this, where the server is running separately, and this is on your application what you would do to build up a cache. So you would have a cache as a static variable, or as some kind of object which, if you're using Spring, which has been injected into the other classes which require it, like a singleton, it would be like one instance of the same bean would be used. unless in some special cases you can have 2-3 caches. Like you can have one cache for some Java objects, you can have one cache to store images, you can have another cache for encrypted values. That is the exact setup which we were using in my previous company, where which most people would have used if they've done a 3DS transaction in India, because we used to do it from banks like Axis Bank, ICICI Bank, where we used to use remote caches, and we saw great performance boost when we started using it in the year 2010. So it's been running now for like 3 years, and it's been going very well. So now I'm testing from my code a key, and then I'm saying what this is the key, some key, then this is the expiry time, and this is some object which happens to be a string, and then I'm trying to get the object, and of course I can get it from in another JVM totally, because it's a remote cache, so it can be between different clients who are running on separate JVMs. It could be on a separate box or a separate physical location as well. So if you go ahead and download the sample application, I've included some exercises. This talk also will be downloadable, this PPT presentation, and I exported in PDF format. And things which you can do are like, read value from terminal after setting it in the UI, and you can wait a few minutes and see if it's expired or not. So that is one using cache, that you have to have a backup plan. So a cache is highly available, but it is not like a database where the database provides you with a high reliability. So a cache could have gone down. There could be a network problem. The client might decide to drop a few requests because it's being flooded with too many store or too many read requests. And so you have a backup plan, which means that you tell the cache that, hey, go and get me this key, but then if the key is not there, you need to be able to go into your database or to recalculate the value or read the file from the disk again. So it's a performance and scalability boost. It's not the end-all solution. And origin failover is where you hit one server, but even if that server is down, then you might have horizontal scaling on your app server, where you can go and hit another server and get the same data which your web server is requiring. And touch and get is a concept where you have stored an object before, and you want to tell the cache that, hey, keep it 5 minutes, but if somebody requests it again after 3 minutes, then keep it for another 5 minutes. So you might not know if this item is going to become popular or not, but as long as it remains popular, you want it to remain in the cache, and once its popularity goes down, then you want the cache to automatically remove it, which is very useful in today's social applications, or even in a static website like serving a blog or some other articles. So you might have some article or some thread which is famous for a few days or few months, and then it becomes less famous and other items will come in its place. So you don't want it to lock up your cache, and you don't want to go and manually clear it. So you can have this touch and get and extend the expiry by incremental amounts, and then finally it will get out of the cache when it's not being used when it's not being requested by end users anymore. So now we've seen about where you can use a cache. You can use a cache for images, you can use it for calculated values, you can use it to improve usability, you can use it for scalability, so that instead of hitting the database, you can instead use the cache, because it's much faster to go over the network and RAM than to go to a database and have the database read a physical file. Though that's much more reliable, it's not the fastest. So, but there are ways how you can abuse cache. And when cache, what will happen is that the cache will not perform as well as it could have. It will run out of memory. It will it'll be taking up too much time in garbage collection and in maintenance and trying to figure out what to clean, what to keep, things like that. So if you a large amount of data which is just specific to one user, which no other user requests, but you're still caching it. So what will happen is that unless your application is only composed of 2-3 users, if you have like hundreds of users or 10,000 users and more, then if you cache specific data to each user, then you'll really need a hell of a lot amount of remote caches, which will not be feasible, and your application will again start crawling. And then another way how to abuse a system, a cache system, is that when there is some kind of, I will explain, like a thread or a new post with some very nice image which a lot of people are liking this week, if you give like an expiry of 1 month or 10 months, then again next week when there's some new funny image, some new blog post which is very famous, then it will all start piling up, and again it will be like the first problem, that you'll have too much of data really using, and your cache also will get flooded with too much of content, which is not, and it will not be able to handle it. Sometimes we also, just because we don't have time or we don't know how to implement things exactly, instead of caching on the web layer, we start caching on the app layer, and things like final web pages, which are common to, you need to cache on the web layer, whereas something like an encrypted value, you would probably want to cache it in the app layer because it does not make sense and is out of place on the web layer. Of course, if there's some data like an OTP or something which is only going to be used once, then it probably does not have to go into a cache. Though if your whole application depends on serving that OTP and verifying it very fast, then there are instances where, again, just like all requirements, you have to talk with the business, do some calculations behind, what is the quantity of data and what is the latency which you want to, what is the the turnaround time which you want the user to experience, and then decide what to cache or what not to cache. So what might be one person's abuse might be another person's requirement. So that is also something which you need to think about and evaluate if you decide to use caches. So the next thing is that how are you going to measure that, oh, I decided to use caches, but